Hello everyone, welcome to my channel Suraj in Cloud, and I'm Suraj Narvade, and today we are going to explore the Kubernetes task. So task is like part of documentation where it's like an example what we saw before. So we'll wait for like few minutes so that others can join. Meanwhile, you can introduce yourself in the chat. Where are you from? What time it is? Yeah. Hi Rohit. How are you? Good. So nice. In For those who didn't attend the last live stream, the it's public on my channel. You can check out that previous live stream. In that live stream, what we did was we 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 covered this website called Cube by Example, which has all the concepts covered, all the basic concepts such as pod label deployment, and like enough to get you started understanding and learning Kubernetes. And we also saw Kubernetes architecture. So if you have missed the previous live stream, you can check that out on my channel. And after that live stream, I mentioned that we will be doing more basic kind of live stream, moreover on the Docker and the container. But unfortunately, this week I couldn't get much time to prepare for that. But I came up with a plan of starting a Kubernetes task, which we will do today and in upcoming live stream, and then we'll go back to the Docker and container basics, right? So I think some new people have joined. If you're watching, introduce yourself in the chat. uh, I'm Suraj. Let me start with myself. I'm Suraj. I'm a senior platform engineer at RVU here in London. I mostly work around Kubernetes, AWS, and Golang and stuff like that. Nice. So I think we should get started. So today we are going to see Kubernetes task, as I said. Okay, let me share my screen. Here are the Kubernetes tasks, and in the video title I also mentioned that this is important for people who are preparing for CKA exam. Now I gave my CKA exam almost 3 to 4 years ago. From then many things has changed as part of exam, but like from preparation perspective or like understanding the concepts and stuff, it remains same, right? Now in exam you have access to the all the documentation in the Kubernetes, so you can refer it, right? But in that exam, we should exactly know where to look for. And one of the key section which was very helpful for me was task. Okay. Whatever question comes in, let's say the question says create this kind of secret, go for it, or like add a init container to it. So I will just go to this task and I exactly know where to find the similar example, and I'll just use that snippet and solve my question in the exam, and it just get easier, right? So being a familiar with the task section is very important, as I said. Now inside the task there are various sections, such as about the administrating the cluster, about pods and configuring the pods, about the observability such as monitoring and logging. If there is any question of logging, we exactly know where to go, right? So making a memory map around this is very important, let's say secret and stuff like that. So to have that memory map, what I followed in the past is try each and every task multiple times, understand it and understand where it is, right? So in exam, it's easier for us to uh, visualize and see where I need to go, because this is not a high school exam where you need to memorize, right? Everything is there in the document, and we are allowed to use the document as well. So if that's cool, do you have any question about that? You can ask in the chat as well. Now in today's stream, what we are going to do is we are going to explore this task section, but we are going to do it step by step so that it won't be too much at the same time. So in this stream, we'll just focus on few parts of this task section, and then we will go in the next streams, we'll explore other tasks, right? So in this particular task, what we are going to see, we'll see that. Now before that, here are my social handles on different social media. If you feel free to reach out to me via social, or if you have any questions or anything, or if you have any suggestion about what should I cover next, let me know via my socials. Even in the last stream, we discussed this, what we can use to try out these things. So you can use Minikube, you can use Kind, you can use MicroKTest, you can use Red Hat Code Ready Container. All these things are these projects are there to spin up your own local Kubernetes cluster on your laptop, on your machine, right? You can use any of this if you are trying this along with me. From the task section, we are going to cover only this section, configure pod and containers, and from that, these 5 topics we are going to cover today. Now if we go to task, the third section is configure pod and container, and from that we are going to, I have selected few topics which we will cover today, such as assigning memory resources to container pod, assigning CPU resources to containers and pod, configuring a volume, configuring a pod initialization, meaning init container, and configuring a pod using a ConfigMap. Now why I selected this topic for this stream is because in last stream we saw the Kubernetes by example, which were the basics, right? Now on top of that basic, we'll now pick pod and we'll try to perform all the tasks around pod so that our concepts are cleared with pod. Okay, and in next stream we'll take rest of the task and slowly we'll try to cover the all task section so that we are prepared for the exam, right? And this is not just the exam focused. If you are working as a DevOps, or if you are aspiring to be platform engineer, SRE, DevOps, and want to work on Kubernetes, knowing these things is very important. So don't think that it is just exam focused. It is going to help you in your day-to-day work as well, right? I think Rohit has asked one question on the chat saying which material we can use in the exam. So in exam, you are allowed to use the Kubernetes documentation website. From the website, this documentation, you can refer anything that you want except the blog. I think it was like that when I gave the exam. It must have changed. We need to check. But as far as I know, we can use all the website, this Kubernetes documentation website. So knowing the website in and out where the things are is very important, particularly task, right? And I'm going to use CO Cloud because, as I said, I use M1 machine, which is the Kubernetes on M1. The Docker desktop, it doesn't work well for me, so I have just spin up a cluster which I will use. Okay, so let's not waste the time and let's start with our first task, which is assigning memory resource to container and pod. So we will go to the documentation, we'll try to follow the examples which are there, and at the same time we will see what it is trying to do. Okay, now if you have any questions, feel free to put them in the chat and I'll address them while we walk through it, right? So let's start. Assigning memory resources to container and pod. Now with this, what is the first thing you need is a metric server. Now if you are using Minikube, you can just enable the metric server add-on and it will install the metric server. And basically what this metric server does is it will show you very basic metrics such as CPU consumption, memory consumption, and like that, and how you can check if metric server is there by doing kubectl get API services. Now I already have metric server installed. We can check that in my kube system namespace. It is already installed, and they are saying if you can check kubectl get API services, and it should have metrics.kts.io API. Let's check that as well. If I search for metric, yes, I do have metric server enabled. Right now the example is memory, so we'll just follow what they are doing. It is just creating a new namespace called memory example. Now we will switch to that namespace. Now this change ns is I have set alias to switch the namespace, but you can use, like, there are tools like kubectx and stuff which you can use, or you can set your own alias as well to change the namespace. And at the same time, current ns is I had just set a alias to see what current namespace is. Nice. So we have created an example namespace. Now let's look at the example and what it is doing, right? So I'll copy this example and pod.yaml. I have saved the file. Let's look at what pod looks like. It's a normal pod, what we have seen in the previous stream, but along with that, what it is doing is it is adding a new thing called resources, where we are saying request is 100 MB and limit is 200 MB. Now what is this request and limits, right? Request means whenever this pod will spin up, the pod will request 100 MB memory from underlying node, right? And the limit means 200 MB, means the request can go up to 200 MB max. It cannot go beyond that. So the usage of this container will be between 100 MB and 200 MB, right? Now we will see if our memory request is within that, how it will react. Okay. Now the example that they are using, in the example they are saying use 150 MB memory. Okay. So this is the sample example which will use that memory which is there. So what we will do now is let's create this pod and see what happens. The pod is creating, the pod is running now. If you see the status, yeah, pod is running. Now if we describe on the pod saying kubectl describe pod memory demo, let's see what it says. We don't see any error. The event looks fine. It just started a container. It is showing the request and limits that we have set. As I said, request is it will get 100 megs by default, and it will go up to the 200 meg, right? And we can't see anything else. Our pod is running fine. Now next thing we wanted to check is how much it is consuming, right? Now for that you can use this command called kubectl top. Okay, now let's check what that means. If I do kubectl top pod, it is showing the CPU and memory consumption of my pod. Now it is 150 mi, as we can see. Okay, we can also give like a name of the pod as well. So it is using exactly 150 MB, right, which we have given. Now what we can do is, let's say in the argument we'll say use 170 MB, let's say. Okay, kubectl apply pod. Oh, it failed for some reason because we cannot change that field, so we may need to recreate the pod. Okay, meanwhile we can see what it is doing next. Next example, it will try to exceed the memory limit, right? Currently we are within the limit 100 to 200. In the next example it will increase, it will go beyond the limit, and then what will happen, right? So just that, and then we'll see what happens. Cool, my pod is deleted. Now let's see what happens. Now my pod is still running, and now if I do kubectl top pod, you will see it has gone beyond 150, right? Because even if I added limit the usage, it will slowly increase the usage, right? That's why, but it has increased. Now what we'll do is we will add more usage than the limit, and let's see what happens. Okay, that's what we want to see. It takes time for deletion. This was the bit which we want to see exceeding. Not sure why this is taking the time, but it should have been really quick. Now what I will do is, in the argument I will say use 250. Okay, and let's apply it. And now that we have applied, the status is showing killed. Okay, now let's describe on the pod as well. And if you see, it is saying back off restarting failed container, and in the state we are seeing this crash loop back off, and the reason is killed. Now what is killed error? Okay, killed stands for out of memory killed. That means we requested memory which is higher than the limits that we have set. So the Kubernetes said it won't be able to satisfy because it has already been there, so it will just throw the error killed. Now to fix this, what we may have to do is, let's say our application is a bit heavy and we need to have 250. In that case we may need to adjust the limits. Right, now once we update that, the killed error will go away, right? So should we try that? But I think it will error because last time we did that, it errored for us. So let's first delete it. Now to save the time, I'm going to add this flag called force and grace period 0, so it will immediately delete the pod. Okay, now I will increase my limits and I will set it to 300. And now if I apply the pod, it shouldn't be erroring out with killed because I have increased the limits, right? So we saw how we can set the request and limit, what happens if the pod requests more memory than the limits. Now that doesn't mean the underlying node don't have that memory, right? It does have, but Kubernetes says I can only give it to you until 200. Beyond that I cannot. That's why it failed, right? Exceeding containers limit. Now next section they have is about memory request that is too big for your node. Okay, so for that we'll just use the same example, but what we are going to do is we are going to request only more than the node. Okay, and then let's see what happens. And then we'll see what happens if you don't specify and stuff like that. Okay, now let's see top as well, and you can see now the usage is beyond 200, right? So let's delete this pod for now. And now for the same pod, what we will do is we'll request more than the underlying node. Now my underlying node has like what, 2 gigs of RAM. So if I request more than that, and the limit I'll say, now these are like very unrealistic number, but just to see how Kubernetes will react to it. So if I do this, let's see what happens. In this case my pod status will be in a pending, right? Now in this case we'll again describe on the pod, and let's see what the error says. So the error says failed scheduling and 3 nodes available, 3 insufficient memory. So it said there is no node in the cluster to satisfy this memory request, so it is not going to schedule that pod. Okay, now if we see that was it scheduled to some node, so it was not able to schedule it to some node because there's no node available which has that memory available on it, right? So we saw that as well. And there's just one last thing which they have mentioned is what happens if you don't specify a limit. So if you don't specify a limit, there will be no upper boundary on the usage. Okay, it will use as much as it can on the node, and once it hit the limit, then it will get killed. Okay, or you can set like a predefined limit in the namespace, like any pod in this particular namespace will not get, and I think you can set that with the help of limit range. So I haven't defined a limit range, but if we search for Kubernetes limit range, in the limit range I think you can configure the how much a request and limit per container in that particular namespace. You can define that, right? So if you don't specify anything, either it will respect the limit range which is set, or it will just use whatever on the node, and once it hit the, like, it's not getting more than that, then it will be killed, right? But it is always good idea to mention the request and limits, because then you can ensure the effective utilization of your cluster and the node, right? So it's always good idea, else it will use as much as it want. and the last bit is cleanup. So I will do the cleanup, and with that we have covered the different scenarios in memory resources, how we can set up the request and limit, how pod gets a value in between, how we can check with the help of kubectl top, and what happens if the pod request memory more than the limits. So we have seen all that, and with that I think the first section is complete, and we will now clean up that namespace and move on to the next task. But before we move on to the next task, which is assigning CPU resources, those who are watching, if you have any question, do let me know in the chat so I can answer, or like we can discuss on it. Okay, so memory part is done. We will move on to the CPU resource. So is that okay? Should we move on to the CPU? Okay, I take silence as a yes. Let's move on to the CPU resource. Now, even to look for CPU, as per the doc, we need to have metric server, which we already checked. Okay, Rohit asked a question, is there any limit to give memory? Now, the request and limits that we set, it is totally depend on what kind of application you have and what kind of node you have in your cluster. For example, there is a Java application which is like memory intense. You may need to set limit at 1 gig or 800 MB, and you also have to consider the underlying node, how much it has. But usually what I have seen in my experience is, if there is any new application, we initially set limit. Let's say I will set 100, 200, and let's say the pod got killed, so that means 200 is not enough, so I'll increase the limit, right? And it's like trial and error. You keep trying and unless you get the exact request and limit. So it's totally on use case basis and trial and error, but it's good idea so that one pod won't eat all the resources in your cluster, right? So it's always good idea. Hope that answered your question, Rohit. Cool. So I think there is some lag because of streaming, so but that's fine. Okay, cool. So let's start with CPU now. Okay, so as I said, the metric server is already there. Let's create this new namespace called CPU example, and let's switch to that namespace as well. I'm trying to keep exactly similar so that whenever you will try, it won't be different, right? You'll get the exact same thing. Now, similar to memory, you can also set request and limit for CPU as well, right? In memory, the units were oh, I forgot to discuss that. The units are usually where like KB, MB, GB, right? Similarly, for CPU, the resource will be like milli CPU or like a 1V CPU. Now, different cloud provider has different terminologies for the CPU. Okay, and in this doc you'll be able to see, in AWS world they say vCPU, in GCP world they say core, in Azure they'll call it as vCore or like hyperthread. There will be different terminologies, but the fundamental unit will be like milli CPU or like 1 CPU, like that. Very similar to what we have done so far. So let's get rid of previous example, and let's save it. Very similar request and limit. In this particular example, we are saying that I'm requesting 0.5 CPU and the max limit will be 1 CPU. Okay, and the example will request CPU more than that. Okay, now do we have any pod already here? We don't have. Okay, now let's apply the pod and let's see what happens. Pod is running, right? Now this arc section, as I said, it is attempting to use 2 CPUs, whereas the limit we have set is 1, right? But the pod is still running. Now if we describe on a pod, we will see no error at all. Okay, and if we do kubectl top pod, oh, metric is not available yet. Why is that? Okay, metric server is there. Okay, for some reason metric is not available. That's fine. Yeah, so we'll get back to that where the metric has been defined, but let's see what it is saying. Once they do the top, it is showing that 974 milli-CPU is being used, which is less than 1 CPU, but we have set to request 2 CPU, right? As I said, the container is allowed to 1, but it is being throttled. Okay, now what that means? Okay, for some reason the top is not working. Okay, oh, there is no metric. Interesting. Why there is no metric? Anyway, not sure. But what's happening there is, in case of memory, what happened was, despite the limit is 1 and the request is 2, the application throttled the CPU usage and it reached to 1, but it cannot cross that, right? But it will try to reach that. Whereas in case of memory, if you request more than the provision, it will straight away says killed. Okay, now what will happen here is, your application will try to use as much CPU as you can till 1, which is the limit. So what will happen here is, your application will keep working, but performance might degrade. The speed of processing might degrade because it is not getting the CPU which is required. Right now, cool. These are the unit. Now there is one more section where it says specify a CPU which is too big for it. Okay, so we'll try that. Was there a C group error somewhere? No. Okay, anyway, let's try scheduling the bigger ones. 100. Let's see what happens. Okay, first delete the existing pod, grace period 0. We have deleted the example. Now in pod we'll set unrealistic value, which is like 0, 100 and 100, which definitely my underlying node don't have that much CPU. So let's apply this pod and let's see what happens. Again, similar to memory, the pod is in pending state, and if I describe on the pod, it will say insufficient CPU, no node available to spin up this particular pod. Okay, it will be in a pending state. And oh yeah, failed scheduling, as we saw in the error, it will do that. Now, next question, what if we don't specify CPU limit? Now, similar to memory, if we don't specify anything, either limit range, if from the namespace, it will respect those requests and limit, and even if those are not defined, then there is no cap. It will just use all the available CPU which is available on the node, right? And if it is requiring more, the performance may degrade, or you have to like keep investigating, does it need more? If it needs more, you may need to schedule it to the bigger nodes, right? So that was more about the yeah, that was more about the CPU usage. Okay, I think one thing I missed was no, I don't missed anything, that's okay. So cool, this was more about the CPU. So we have seen what happens if you request more CPU than the limit, what happens if you specify unrealistic value which is like even bigger than your node. We also learned the pod won't get killed, like it won't get stopped like how it got killed with memory, but performance might degrade. That's the one thing we have seen. Is there any questions or difficulties with the CPU? Now, setting the memory and CPU request per container or like per pod that we have seen, it's kind of very important in the production scenario where you have a cluster and you have to optimize the usage. That's where setting the request and limit is like important. And if you're looking from exam perspective as well, I'm pretty sure there will be something around this. Yeah, cool. Is there any question, or we can move to the next bit, which is configuring a pod to use a volume for storage? Okay, so let's move forward and let's look into the configuring a pod to use volume for storage. Now, if you have seen the previous stream, in the cube by example that we have already seen a volume here, but I will revise it for the next bit, which will be useful. Okay, we have seen the volume, but in the previous stream we haven't seen the request and memory, so that was good. Nice. So let's first clean up our previous thing. Okay. Now, why we need to use volume, right? Now, we usually say that containers are ephemeral, they can die anytime, they can recreate anytime, but you may need to persist some data, right? In between the states, in between the container restart, you may want some data. Or as in the previous stream we discussed that a pod can consist of one or more container. There may be a use case where you want to share a data between one container, the containers inside the pod. So that's where you need some third place where you can dump something and which can be reused, and that's called volume, right? And now in this example we'll see how we can use a volume for a given pod. Now the volume which we are going to see, it won't be persistent volume, it won't be advanced level volume, it will be very basic mtdir volume. Okay, now mtdir volume, it will be there only, it lasts only for the lifetime of a pod. Okay, now till the moment pod is there, this volume will be there, which will be there in memory. Once the pod dies, the volume goes. But if the container inside the pod restart, the volume will remain same. Okay, now we'll see how we'll try to perform this, and in the next exercise we'll see why this was useful. Now this is our example, right? The Redis container is there, and what it is doing is it is defining a volume of type mtdir. It is no fancy volume, very basic type of volume, and we are mounting that volume at /data/redis path inside the Redis container. Okay, now did we created a new namespace for this example? Actually they haven't, so let's just use the default namespace. Okay, now this will create my pod. We can do kubectl get pods with -w. We can watch the pod, and our pod is now running. Okay, now describe is like one of the very helpful command. You may have seen I use describe command quite a lot because it gives a lot of information in like a nice readable format. Now in this you'll see the volume, it was of type mtdir, and it does say it's a temporary directory that shares a pod's lifetime. Okay, pod dies, volume dies, and it is mounted at data redis, which we have defined. Okay, now what this example is doing, what they will do is they'll go inside the container. Okay, create some sort of file, install few things like a process, something, then we'll kill the pod. Okay, and then we'll again go inside the pod and see if the things are there. Okay, that's what the exercise is. And what they are doing, they are installing this called proc ps, which install the ps command to see the existing process. Okay, cool, let's do it. We have this pod running. Now if we exec into this redis pod, and our mount was /data/redis, right? We can check with pwd, we are here. Now what we will do here is we will say hello Suraj in cloud, and we will add a file called hello.txt. Now if you see the file, it has my content. Okay, now I will exit the container. My container is still running, and let's also run some command in it. Okay, can we do this? Yeah, we can. There is a hello.txt file, and if we do get hello.txt, there is a content of my file there, right? Now we are not going to delete the pod, we are deleting this particular container, but how we can delete the container, right? So that's why in this example, if you see, they have installed this new thing called proc ps, and then they will kill that particular process, meaning that container, and it will restart the pod to replicate that, right? But if you have used deployment, you could have very much easily deleted that and see that thing exist. So we'll just follow their example, so it will be just easy for us to demonstrate. So we do apt get update, I think it's Ubuntu based, and then we install proc ps. Now if we see ps aux, like similar to how we do on the Linux, you will see that the Redis is running and bash is running and ps is running. Okay, now we will have to kill the Redis process. Okay, kill PID. The PID means process ID of that thing, so we will kill it now, which was kill 1. Okay, and now if you see, the pod got restarted because we killed that process, and because pod is maintaining the state, the container got restarted again. And now if we go inside the pod again and go inside the data Redis, and we will be able to see the hello Suraj in cloud there. Okay, so our file persisted even if the container got restarted. Okay, but now, as we said, this is like very basic volume, right, in memory. So the pod goes, volume goes. Now let's delete the pod. Okay, and let's recreate the pod. And now if we go inside the pod with the help of this exec command and Redis, and if we do ls, our hello.txt file is gone now. So that's why it said the volume will be there only when the pod is alive or there, right? Now, as I said, there can be like many applications of these kind of volume, like which we will see in the next task now. But to share the data between two containers inside the pod, this kind of things are easy. Okay, we can try this out with various things, and there can be many use cases regarding this. Nice. Any questions till now with regards to volume? Now, using this volume terminology, we are going to see the next bit, and we'll see how it is being used in a real scenario. Okay, nice. Okay, so we have seen request and limits with the memory and CPU. We have also seen how we can use volume, but that was just an example. But now we will see how that volume can be helpful in a real life scenario. Okay, now for that we are going to see pod initialization, mean init container. Okay, now if we look at this pod definition, it's just yet another pod definition that we have seen, but there is this one additional bit called init container. Now it is very similar to this container, but as the name itself indicates, init container, they initialize this whole pod. Means as soon as you start the deploy the pod, this init container will start, it will do its work, then it will go away, and then your main container will run as it is. Okay, that's the difference between init container and container. Now if you have any question regarding init container, do ask in the chat. We'll see if there are any questions. Okay, but these init containers are not supposed to be long running. They'll just do some task and they'll go away. For example, in this example, this init container is downloading a web page in index.html file, it is dumping into this volume, and then that volume is being used in the main container, okay, which is a nginx container. And volume, if you see, is the same mtdir volume which we saw in the previous exercise. That's why I choose the volume before this to understand the use case. Now to reiterate, when this pod will start, this init container will run, it will download the web page, then it will go away. Then when this new container will come up, it will have this volume in it, and it will use that web page to serve it. Now you must be wondering, why not just download in this container, right? Why to add one more step? But in production use cases, for security reasons, we will use this image like very small size, or will remove all the unnecessary tool. Now to run nginx, there is no need of having wget command inside that. Now imagine a use case, if hacker tries manages to get access to nginx, he can download illegal stuff with wget. Like, he can download some malicious scripts and run some weird programs in it, and hack the whole thing. So we try to not add all the unnecessary stuff in it. So what we can do is, we can add init container to do that hard work, right? So in this case, our nginx don't have wget, so we just added a new command saying, just download this and give it to me. Now there can be a use case where for your main container, you need some content from one of the Git repository, but you don't want to keep Git CLI inside that container. So you will add an init container, you will git clone that particular repo content, dump it into the volume, and then share that volume with main container. Okay. Now we will see what this command is actually doing. Okay. Do I have wget? Okay, I do have wget. Now it is wgetting -o index.html this. Okay. Now this is some file from info.cern, some file. Okay. Now that page will be downloaded, shared with this main container, right? So now when we'll run that pod, we should be able to see this content. Okay. Now let's download this pod template. Okay, I added it. Now let's apply the pod, and if you look at pod, you will see init 0/1 means init container ran, pod is initializing, init container did its job, it's gone now, and now the main container is running. Okay. Now if you describe on this my init demo pod, you'll see it first did pulling image busybox, which was the init container, this one. It did its stuff, then it pulled the nginx image, which was my main container, and then it did its work. Okay. And in the description you'll see container nginx, init container, and some stuff. It completed without any error. Now we put that file inside usr share nginx html. Okay. Now, and it is hosted right at the port 80. Now we saw port forward command in the last stream, right, which basically exposes that pod to my local host. Now let's try doing that. Init demo, I will expose it to localhost port 80, and 80 was the container port. Okay, now if I do localhost 80, we saw the exact same page which we saw here. Okay, there is some from here you can content, home of the first website content. See, from here you can in the home, and that's the one way to test it. And other is we can go inside the pod if possible. Init demo -- bash. Okay, and what is the path? This is the path. Okay, cd path, and this is the exact web page that we saw. So this is how you can like minimize your main application container, and like you can use like init container to do some things and use it for your main container. Right now it can be anything, as I said, downloading few stuff or pre-populating few things, stuff like that, right? So this was about the init container. Any questions from the init container, as it was based on volume itself, and it's init container. Even in production scenarios, init container can be very helpful as well for many things. Any questions with the init container? No? Okay. Cool. So if there is no question, we'll move to our last bit of today's session. I will try to keep this stream. I decided that I'll keep the stream, as minimal as possible, so that like as a viewer you also can like try things alongside me, and we can like do it together, and it won't be boring as well. Cool. So to just recap, we saw CPU, memory, volume, init container, and the last thing which is very important, and which we didn't cover in the last live stream, is the config map. Okay, but we did cover secret. Now, as you know, the secret is a resource in which you can put like a sensitive information, but we can't consider everything as a sensitive, right? There will be some element which are non-sensitive, but you don't want to bundle them inside the pod. So in that case, what you will do is you will define a config map. Now name itself indicate it's a map of a configs. Now config file can be anything. For example, in logging pod, how the logging configuration will look like, or your app needs a configuration from a set of files, you can define everything there. Somnath is saying I always late. That's okay, Somnath, no worries. I will like after this stream anyway, I'll upload, and you can watch it there as well, so that's fine. But just to give you an idea, this stream was like next piece of my previous stream that we did. The previous stream was moreover like the basic concepts from the cube by example that we have seen, and in the stream we saw these 5 concepts from yes, I do remember you from the Twitter. Yeah, and as I mentioned over on the Twitter as well, the in the YouTube video description I did mention that we'll cover these 5, and in upcoming stream we'll try to cover the rest, so that even if you are a beginner or if you are preparing for the CKA or those other exams, it might be useful for us. Okay, so that was pretty much of it. So the last bit is config map, saying it's a map of a config. You can pass any sort of config that you want. Let's say in this particular example, they have two configs called game.properties and UI.properties. Yeah, that's okay. Cool. Now, how does this config map look like? Again, it's a Kubernetes, so it will be kind config. And in the now, this is like a special, I won't say special, but it's a different resource than pod and deployment. So it doesn't have spec, but it has data field. Like usually in pod and deployment, you will see API version, kind, metadata, spec. It has data field, and this data field is a map of config. Now in this data, and as you know, in any map, what is there? It's a key value, right? A map is like a key value pair, and like there will be many key value pairs. So similarly in this map, game.properties is a key, and these are the values in that file, in that configuration. Similarly UI.properties, and this will be values in that, right? Now you can create config map from these files, and it will also show you maybe how you can use that config map in the pod. Does it showing that? Okay, yes, there is a, it will show that how you can use. Okay, now first we will see how we can create the config map, very basic thing, from a file. Okay, so let's download this file. What it is saying? Okay, it didn't like the path. Okay, we downloaded this game.properties, and now we will download this file, UI.properties. Now these are just configuration file which our application will need. Okay, and you will not be able to bundle this in the container, because container image should be like just your application, not any configuration or anything inside it. Okay, now we have the configuration file which we will need. Now let's create it. Okay, for that they are saying you will have to do kubectl create config map game config, and then from file. In from file you can either say directory or you can mention individual file. Okay, now that I don't have directory, we will see from individual. Okay, now the command is kubectl create config map. Now one thing here is you don't need to refer document always. Okay, you can just do -h and it will show you all the flags which are there, but I'm not interested in that. I'm interested in this examples. So let's say you are in exam, right, and there is a config map question. You can just do kubectl create config map -h, and you can see the example, and based on that example you can create a config map. Now in my case there are two files, so I'll use this example, from file key 1 this, from file key 2 this. Okay, and you can mention the directory as well, we will see that as well. And one more example which we are going to see is from literal, where you don't mention the file, you straight away mention the, this is the key, this is the value, it's just one word. Okay, so let's go with our first example, config map. I will call it as config map 1 from file. Now I need to give key, right? So I will say UI.properties, and this is my file. Okay, now another file is game.properties equal to game.properties. Now it created the config map. Okay, now if I describe on that config map, I will see the data field which we saw in here. Okay, game.properties with all its things, and then UI.properties with all its information. Exactly similar, and that's how you can create config map. Now similar to this, you can do one more thing. You can like create a folder. Let's say I will call it as configs. Okay, and I will move my UI and game properties to that config. Okay, now if I do config, I have this file. Now I can do kubectl create config map. I will name it as ConfigMap2 from file, and I will mention the directory name. And now what will happen, the kubectl will go into that directory, look for all the files, and it will create config map from all those files. Okay, very similar. Now let's say you don't want to create the config map, but you want to see how it looks like, or you want to store the config map. So you can just do -o YAML and dry run. Okay, so if I just run dry run, it will say config map created, dry run. That means that it didn't create, but it verified that whatever configuration I had, it is correct. And if you pass -o YAML flag, it will give me a YAML which you can store in your Git repository and something for like infrastructure as a code stuff. So this is how you can create config map. If you have any question, do let me know in the chat as well. So we have tried this, and now we are going to try their example how to use this config map inside the pod. Okay, for that what they are going to do is create the config map but from the literals. Okay, so for that I'm going to copy paste their example. Okay, this is the example. Now first we'll do dry run. Okay, to avoid that error, we'll say dry run equal to client. So our configuration is correct. Okay, now let's look at YAML file. How does it look like? So in the data, the key is special.how and the values vary. It's very basic config map. Okay, now I'll remove the additional flag and let the config map create. Now if we describe on config map, you will see there is one data with the key special.how and the value is vary. Okay, now is the most important thing, because the whole idea of this stream is to understand pod. We will now create the pod. Okay, let's first look at this pod definition, what this is doing. Okay, here what it is doing, if you see inside the environment, it is seeing value from config map ref. Inside the config map, this is the name of the config map, and inside the config map, the key is special.how. Use that key and use that value. Okay, that's what this pod is saying. Now because this is key value pair, we can use the config map in environment variable, but if it was like a file, then that case you would use that as a volume. Okay, maybe that example is, yeah, here there is one example, so I think we'll go there as well. But before that, let's see how this example goes. Okay, the pod is created. Now if we log the pod, inside the pod, like this pod is like designed to print environment variable, and if you see this particular environment variable, it is set to vary, right, which was the value of the given key from the config map. If you want to see, we can do that. The config map was special config, and if you see, the value was vary. And if you look at pod definition, what we are seeing is in environment, special level key should have the value from the config map, which has key this, and that value should go to the special level key, and which was this, right? So this is how you can use config map as a environment variable. Now you can add multiple environment as well from the config map. Right? So this was the environment variable. Okay. Now we saw volume in the previous exercise as well, but that was like a in-memory volume, and which goes away when pod dies. But the config map will remain there, right? And we can add some config map and add it as a volume. So inside the pod, the data of that config map will be available as a file for your application. Now let's create this config map. Oh, it says it already exists. So first I will delete the existing config map, and then I'll create the config map. Special config, it has two values, special level vary, special level type, and let's see how it is being used as a volume. Okay, now if you look at this pod definition, now instead of using it as an environment variable, inside the volume we are seeing this is the volume of type config map, and inside the mount we are mounting that volume to the etc config. Okay, now let's see what this example do. Now if we save this example, and now if we apply this pod, oh, I think the pod already exists, that's why I didn't like it. So I'll just delete the old pod. I didn't do cleanup after previous exercise, right? So let's apply the pod. Again the pod got completed, but if we describe on the pod, was that config map supposed to be in a default namespace? Yes, and I'm in a default namespace as well. Anyway, but it does saying mount volume failed. Does that mean my application failed? It doesn't look like it failed. Must have been random error. Now if I check the logs, you can see special level and special type gets printed. Okay, so if you see, the output should be this, which we proved. Now you can customize things, like select this particular key and mount it to the particular key and stuff like that, and that's how you can add config map to it. Right now, from the topic perspective, we have covered pretty much everything in config map as well. Now from the production experience perspective and from the uh, exam perspective, if you are preparing for exam, all these topics are very important. So I would highly recommend to try this out on your local machine using like the clusters that I recommended, either minikube, kind, microkits, anything, because in exam the practice is the key. Because if you are hands-on and if you are aware with the task, where each task are located, how to refer the examples, where are the examples, then it becomes quicker and easier, right? So just to recap, we saw memory and CPU, how we can set request and limits. We saw how to use volume, and with the understanding of that volume, we saw the init containers, how they work. And then on the similar concept, we saw the config map, what is config map, how to create one, and how to use inside the pod. So this was my target for today's live stream, and in upcoming live stream we'll take uh, more topics from the Kubernetes task section, and will understand more and perform them as well. And in next few streams, as I promised, we'll cover the basics of container and Docker, right? And also along with this, alongside the streams, I do have one active playlist called EKS Tales, where like I explore various aspects of Amazon's EKS. Do check that out as well. So now I think the topics are covered, but if you have any questions or like difficulties, or any suggestion for this stream or upcoming stream, or any particular topic you would like to cover, do let me know in the chat. And if you think of anything right now, and if nothing, do let me know in the comment section. And also I do have my socials in the description as well, so do let me know over there as well. uh, yeah, glad you find it useful. Rohit, is there anything? If not, we can call it a day for this stream. And nice, cool. Thank you so much for joining, and have a nice day.